Hello again. In today's tutorial, we're going to be covering configuring an iSCSI initiator on a Red Hat or CentOS7 machine and connecting that machine to a server running OpenFiler as an iSCSI target. At the current time, this particular machine that we're going to be using is a brand new VM that I have created. All I have literally done to this machine is do updates to the machine to make sure that it's at the latest patch level and ensure that there are at least two network interfaces on the machine. I'm SSH'd into the machine, and if I do an ifconfig on the machine, you see that I have a single IP address configured on one of the interfaces. So we're going to go through and we're going to set up the second interface to be able to talk to the iSCSI target and procure storage. Right now, if we look at a df-h to take a look at the current disk, we'll see that we only have a 50 gig disk that's assigned, and that 50 gig disk literally just contains the installation of the operating system and nothing more. So in order to start off, what we're going to need to do first is to download a couple of prerequisite packages. I have those packages set up right here. What we're going to need to do is grab the iSCSI Initiator Utils package, the Device Mapper Multipath package, and the LLDPad package. And the Device Mapper Multipath is just setting up a library or installing a library for multipath support, which we're not going to need for the purpose of this tutorial, but in a bigger enterprise level setup where you have multiple paths to the backend storage for redundancy, that's where we would absolutely need the multipath package and the multipath libraries installed. So we'll start off by going ahead and installing our packages. And once those packages are installed, we want to just make sure that we go through and start any services that we would need to start. So the services that we would need to start is we're going to use system control, being that this is a CentOS7 box and it does use systemd. We're going to start the iSCSI D, and the multipath D services. And the one that we're primarily concerned with is going to be the iSCSI D service. So let's go ahead and check the status on that. And we see that it is in an active and running state. So now the next thing that we need to do is we need to actually configure the interface. And so we're going to go into cd etc sysconfig network scripts, which is where our initiation scripts for the interfaces are going to live. So we see we already have our EN0167 interface here, and if we just take a look at that, we can see that this is the interface that's set up for our primary network access. So what we need to do is we need to set up the second interface to be available and configurable to talk to the iSCSI target. So first, let's go ahead and grab the adapter name so that we can go ahead and set up a configuration file to be able to configure the adapter. All right, clear my screen here. And we can do that just really simply by typing in IP link show. And we see that we have all three of our adapters. So the second adapter, of which we're going to use to configure iSCSI, is actually going to be the third adapter in this particular view. The first adapter being the local loopback, the second adapter being the actual adapter that we're using for inside normal access to the server, and which we're SSH'd into right now, and then the adapter that's going to be the iSCSI adapter. So we're just going to grab the name of the adapter, and here inside of our network scripts folder, what we're going to do is we're just going to copy the ifconfig EN167 adapter file into another file called ifconfig EN0 and then the name of the adapter. Now let's go ahead and edit this adapter. And we're going to want to change a couple of things in this configuration from what is configured for the internal interface. The first thing that we're going to want to change is we're going to want to go down here to the name, and we're going to want to change the name so that it corresponds to the proper name. So that's going to be the EN0335 bunch of numbers in my case. Also, the UUID is going to be different, so I'm going to go ahead and just remove the UUID field altogether. Device is got to match the name. So again, we will remove that designator and replace it with the proper interface designator. We do want it to start on boot, and we do not need any DNS or gateway information in this adapter. So let's get rid of both of those. And we want to set the IP address to an IP address on the subnet that the initiator is going to actually serve storage on. So in my particular example, that's going to be 172.16.79. Let's make this 179. Let's get rid of these extra digits. and the prefix is going to remain as 24, which correlates back to a 255.255.255.0 subnet mask. Now, after all of this, what we want to do is we want to add some initiator-specific information. So we're generally in here, we could set the MTU to be a bigger MTU size if the backend storage is actually presenting the storage using larger maximum transmission units. Generally on a backend storage array on something serious like a EMC or a NetApp or one of the bigger arrays, what's going to happen is they're actually going to jump up that MTU size so that they're transmitting more data per frame through the wire. And that's generally a good idea when you're dealing with storage. By default, Ethernet sticks to about 64K frames. 64K is not a lot of data, and especially if we're dealing with something that is a storage array and it's access to our storage, we want that window a lot bigger. So generally you would set it to something like 9,000. So the iSCSI options that I'm going to configure in the interface are going to be DCB settings, or data center bridging settings, that are an enhancement to Ethernet that just makes it work a lot better with larger data connectivity. The options that I'm going to set are going to be that I'm going to turn data center bridging on. I'm going to turn off or tell it that it's not using fiber channel over Ethernet. I'm going to enable iSCSI. I'm going to set it to advertise iSCSI. Then we're going to go ahead and save the interface configuration, and we're going to go ahead and restart networking. It's network.service, network-d. Okay, and once we've gone ahead and done that, we can just do an ifconfig to make sure that we now have an IP address assigned on that adapter, which we do. Now, the next thing we want to do is to make sure that we are able to talk to the iSCSI target now using that interface. So to do that, I'm just going to go ahead and ping the 172.16.79.180 address, which is the address where my initiator lives. And you see that I am getting a response back from my target server, my iSCSI target server, so that I do have at least a communication pathway from this server to my iSCSI target. Now, the next thing we need to do is we actually need to grab an initiator name. The initiator name should be set up when you install the iSCSI util packages. And so in order to be able to get the iSCSI name that's already been set by default when we installed that utility, all we have to do is do a cat to the etc iSCSI initiator name.iSCSI file. And that will give us the initiator name. Now, typically, again, with a big enterprise setup, something using NetApp, EMC, one of the bigger storage arrays in the back end, what would typically happen is that you would have to take this initiator name and give this to the storage administrator. And the storage administrator would tie a LUN on the back end storage directly to that initiator. So now that we have the initiator name, the next thing that we want to do is we want to perform a discovery to see if we can actually look at and see the storage that's presentable. So in order to do that, I'm going to use a utility called iSCSI, which is the iSCSI admin. ADM. I'm going to use the flag M for discovery, which I'm using the discovery module. And the target is going to be the send targets 172.16.79.180. And we see here that by performing the discovery, I actually was able to find the iSCSI target. It does see it and it does identify with it. If I want to get information about the LUNs that are available on the iSCSI target, then I can use, again, that same iSCSI command. Using the node module, and I'm just going to type in the option of show. And what that's going to do is it's actually going to query the backend storage, and it's going to show me what that iSCSI target is presenting to me, or what I have available. So you'll see I have the first LUN available here, and it's all the information regarding that LUN. And then I have the second LUN here, which is, again, going to show all the information about that second LUN. So at this point, what I need to do is I have connectivity back to my iSCSI target. I have verified that I can see the target and that the target service itself is live and it's responsive. And I can also look at the LUNs that iSCSI target has available to serve out. So the next thing I'm going to do is I'm actually going to log this box into the iSCSI target, and I'm going to do that again with the iSCSI admin utility. And I'm going to again use the node module with just the -- login. We can see that it made 2 attempts, It made an attempt to communicate to the 172 address on that particular iSCSI target, and that attempt was successful, but then it also did try to attempt to log in using the 10.79, and it was blocked. And the reason why it was blocked, which we want it to be blocked, is because we have that network access control list set up on the open filer that disallows any connection from the 1079 network. It's only allowed to the 172 network. So now that we're logged into the iSCSI target, we should actually be able to see that backend storage. So let's go ahead and test that. And we can do that by just taking a look at proc partitions. And we can see here that we've got our SDA disk. And our SDA is going to be the disk that we actually have the OS installed on. But now we've got SDB and SDC, which are going to correspond back to the LUNs that we defined in the open filer setup in an earlier tutorial that we've now logged into and procured on this server. So at this point, I have the full ability to be able to go ahead and format those LUNs, because right now we do not have them mounted. If we do a df-h again, we see that we still don't have anything mounted. All we have is the SDBA disk. So in order to get that all set up to be able to mount it, let's go ahead and use fdisk. And we're going to go ahead and fdisk dev SDB. So in order to use fdisk really quickly to just throw a partition on there, we're just going to select new for partition. It's going to be a primary partition. The partition number is going to be 1. We're going to just go ahead and use the default first sector and the default last sector. And then we're going to write those changes to the disk. And then we're going to go ahead and do that same thing to SDC. New, primary, write. Okay? And now that we have partitions defined on those two disks, now we need to actually go ahead and put a file system on those disks. And we will do that with makefs.ext4 dev SDB1 will be the new partition that we just created. So let's go ahead and create that. And then let's do the same for SDC1, which will be the partition that we created on the SDC disk. So now at this point, we've not only connected to the backend iSCSI storage, but we have also procured the storage, logged in, and we have that storage assigned to this particular server. And then in addition to having it assigned to this server, we've put a partition on that LUN, and we've also put a file system on that LUN. So now the only thing that we have left to do is actually mount that LUN. And the way that we'll do that is we're going to open up the fstab, and we're going to throw an entry all the way here in the end. We're going to point to the dev SDB1 partition, and let's go ahead and mount that to mount, we'll call it iSCSI1, and this is going to be an ext4 file system. That's what we just put on it. And the options are going to be defaults and netdev and 00. And then let's go ahead and duplicate that entry. For iSCSI 2. So this will be SDC1, which we're going to mount iSCSI 1 and iSCSI 2. Now, we do have to make sure that we create these directories because they obviously do not exist by default on the system. So let's go ahead and save the fstab, and then let's go ahead and make those two directories. And once those are created, then all we should have to do to mount the storage would just be a mount-a for mount all. And it looks like we spelled defaults incorrectly, so that would probably be an issue. So let's go ahead and try that again. Okay, and that looks like it went clean. So now if we do a df-h, we see now that we have two 25 gig LUNs that have been assigned to the server that are being served from our open filer iSCSI target. So that about covers everything I wanted to cover in this tutorial. Stay tuned. Take a look at our other tutorials in this series to see how to mount iSCSI storage on Debian or Ubuntu-based boxes, as well as setting up the actual open filer installation and configuration, which are available in other videos in this series.